Year 10 end of year, long answer question solutions. Question 1 part A, there are many isotopes of the element molybdenum. What do the nuclei of different isotopes have in common? They have the same number of protons. That's what they have. That's what makes them a particular element. Now, same atomic number is not enough. It's about the number of protons. Same number of protons. Part B. What happens during the process of nuclear fission? It has to be nuclei or the nucleus splits. You cannot talk about atoms. With nuclear physics, you cannot talk about atoms. Always the nucleus. Part 2 of B. Where would it be produced? Well, it would be in the reactor. When the nucleus decays, it emits radiation and changes to technetium. And we're asked what kind of radiation? Well, we see that the mass number hasn't changed. So it could be beta, it could be gamma. But we see the atomic number has gone up by 1. Gamma doesn't do that, it's beta. So the answer here then is beta for part C. Because the atomic number goes up by 1 and the mass number is unchanged. That is the reason. Technetium-99 has a short half-life and emits gamma. What is meant by the term half-life? Well, I would always say it is the average time for half the parent nuclei to decay. You could say it is the average time for the activity to fall to half of what it was before, or the current rate. So that's part D. Part E then. Technetium-99 is used by doctors as a medical tracer. In hospitals, it is produced inside a technetium generator by the decay of molybdenum-99. The figure below shows how the number of nuclei in a sample changes with time as the nuclei decay. It continues to produce sufficient technetium-99 until 80% of the original nuclei have decayed. After how many days will it need replacing? We're looking at 80%. So I would say %, of what have we got there? 100,000. Would be 80,000. So if we come across to 80,000, let me just take a look here. After 80% is decayed, so we're looking at the time to 20,000 nuclei. So if we look 100,000, 20,000, that is 6.2 days, I reckon. Medical tracers are injected into a patient's body. This involves some risk to the patient's health. Explain the risk to the patient of using a radioactive substance as a medical tracer. And we have 2 marks. Well, the tracer emits ionizing radiation. I reckon ionizing is worth a mark. And that damages living tissue. So ionization damaging living tissue. Even though there may be a risk, doctors frequently use radioactive substances for medical diagnosis and treatments. Why? Well, because the benefit outweighs the risk.